All right. So homework today was lead expressions. Okay, how did that go? Well, so I should have made it harder. I'm talking stupid because it's early. I am in a bad mood. I was supposed to get my car back yesterday after not having it for 2 months. And they delayed it another 9 days because Tesla, sends them like 1,000 parts and apparently like left 2 off. So didn't send them 2 parts they needed. One of them was just the hood ornament. Not a big deal, right? The other one was apparently something with the steering. that was a little bit more critical. I don't know. It's called something. It's called the knuckle. I don't know anything about cars, but apparently it's a steering thing. Well, I'm guessing that it does require the knuckle part to do the self-steering. I'm guessing it is something. Oh yeah, the wheel moves. Yeah. Yeah, I presume it's something to do with the what attaches the wheel to the yeah. So I see. And apparently Tesla had shipped it, but it got lost by UPS, is what they said. But every single week I get a report from Tesla that shows here's the 4,000 parts they ordered, and this is when they were shipped, and this is this tracking number, and this is when they arrived. And these 2 line items, the badge and the knuckle, have not had anything on them since the beginning. So I feel like I assumed they were getting the same report. So I wasn't like forwarding it to them or anything. So I don't know if I had been a little more proactive. But now they called and I don't know, yelled at Tesla and said, hey, we need these parts as soon as possible. So maybe they'll get, sent something faster than like postal service ground. Yeah, first class at book rate. Yeah. That's what I'm thinking based on the reports I was getting and how on top of things Tesla seemed to be. To me, I interpreted it as they were like out of stock, like they didn't have them. And that's why everything else shipped. So I'm fully prepared for them to recognize again that they don't have them. And then them to tell me that I'll see my car in 2022.
Oh, so in addition to chip showing you now have a card chip.
Huh? Really?
Yeah.
Like what's out the grocery store? See, notice how she's replaced toilet paper with the word stuff.
I saw something the other day where it was like toilet paper, like milk and ammo.
And ammo? That pretty much makes sense. Like it sounds funny when it hits your ears, but then you kind of like it kind of makes sense at these days. Yeah. Well, my wife said at Meijer that they have the 2-pack max for toilet paper again. Is it?
Yeah,
Yeah, well, it's probably not only that, but it's probably a contributing factor. I don't know. I haven't noticed. I buy all my food at I have a butcher shop that I go to that called Heritage Meats. So I'm on texting thing with Bill the butcher. So we text each other. He tells me we just get something new in. It's like the ultimate fat guy stuff when your butcher is texting you.
No, I won't be too surprised if you get a bunch of just to go.
Yeah. Oh yeah. So lately I've been doing the 45-day dry aged prime New York strip, doing quite a bit of that. There hasn't been a shortage of that. It's actually not bad. It's like I don't know, it's like $29 a pound.
Oh, it's not that bad. I mean, it's
In
not bad.
for that particular product, it's actually a pretty decent price. Although they have these bone-in double cut pork chops there that are like not expensive. I don't know, $6.99 a pound or something like that. But they're good.
Yeah.
I'll put them right up against that New York strip. Yeah. And they're easy to cook. I almost cook all these things now in my air fryer. Yeah, but I mean, air fryer is like super common now. You can buy them at Costco. I mean, it's like the new wave microwave oven. You could cook anything in an air fryer.
Do you have like an air fryer or do you have like a Ninja? Because like there's like a Ninja. But like air fryers, like can you just fully cook meat in those?
Yeah, they get to 450 degrees. Huh? Yeah, but I have one of the bigger ones. But I think the Ninja's the same thing. I mean, the Ninja's an air fryer. I mean, it's got a big compartment thing you put stuff in. Yeah. I mean, I do prepare it some other ways. I have a sous vide at the house, so sometimes I'll cook it with that and then finish it in a pan or something. So it just depends on my mood. But I'll tell you what, air fryer is like super convenient and it comes out just as good. Well, air fryer is perfect for reheating stuff too. So if like leftovers, you just throw it in the air fryer and push the reheat or the reheat button, and it's like perfect. You had to Google air fryer. So I don't mind Sodexo's food. I could have eaten a pan of that lasagna yesterday.
So the question then becomes, are there any air fryers that are 700 watts or better?
Oh, I don't know. Why does it have to be that? Is that a rule on campus?
Yeah.
Like coming to your dorm room, measuring your power drain?
Totally, yeah.
Yeah.
That's where our students of these firefighters just measure the
When I was in college, the cooking rules revolved around the George Foreman grill. You can only have one up to a certain size. You could have the personal size George Foreman grill. But I had the really big one, but I made the argument that that is personal size for me. Yeah, I mean, I'm filling that whole thing. Actually, I'll probably go to my butcher today. He's doing they make their own bacon there, and he's doing bone-in. No, that's not food. I think they're doing bone-in pork belly, but cut like steaks. Man, that's got to be great for you. All right, let's write some let stuff. Man, I'm so hungry now. I hate all of you. How did I go from Tesla to the butcher? Ah, yes, yeah. And then where you guys buy your food. Who buys food at a grocery store? So pedestrian.
Where do you buy your not meat?
I don't eat not meat. Actually, the butcher, they have some other stuff. All right. But having said that, I only buy meat. It's actually an interesting question. I don't eat not meat at home.
You not eat like potatoes?
I like potatoes, but
You don't like
I go out a lot. Yeah, so at home, if I'm cooking, it's meat. All right, we're adding let expressions. So a let temporarily extends our variable environment. So only for the runtime of probably the use case for a let in our current language would be inside of a lambda expression. So you'd have a lambda that creates a let that then operates on the local variables from that let. And then when the lambda ends, it would pass it back up. So if I was writing a, let's give you some sample. Let's rate, oh, that's our environment. Here's my sample no code. What's our syntax for, oh, it's called call, right? We're going to say call function A, which actually is interesting because this does create a shadowed environment. So we already have a variable named A inside of our environment. We happen to know that when this guy gets bound in our environment, he will be more local just because of the order in which he's put into our environment. But that does become a little bit dangerous. In fact, we're going to see why it's dangerous here today, or at least why it could potentially be dangerous today. But actually, it was dangerous here too. Because when we bound this A to whatever value, so I'll finish writing it if we just say, you know, plus A2, something like, do mathy stuff like that. Yeah, it's what no code looks like. So in this particular case, we extend the environment with this A. So 5 comes in for A, shadowing this A as 7. It doesn't overwrite that A as 7. Just gives us a new variable at the beginning, A equals 5, which we're hoping, and because of the way we wrote it, will get resolved first. When we say I'm searching for A, it'll find the A is 5 before it finds the A is 7, so it'll give us the correct value for A. Great. That's more of a lucky happenstance that we can rely on. It's not just a random thing, but will become a potential problem as things get more complicated. And actually, I should be able to show you an example here of where it would be a problem. So this guy should give me here, I'm going to say plus 10 here just for my example. So that should give me a 15 out of that, right? So then I'm going to say, I'm going to have another call in here. Call function on a variable R on a actually don't want to do the do mathy stuff here. I'm making it overly complicated. So function R is going to boil down to the value of A, whatever A happens to be. And I'm going to pass in a 5. Let's see, I'm at the wrong function R. So it doesn't matter what I pass in here. So we'll pass in a 22. I'm not using the value. So 22 is coming in for R. The body of this doesn't even use R. It's just kind of a waste. So it's boiling down to whatever the value of A is. So now I'm going to pass in a 5 for A. So 5 comes in for the A. I then, what's the body of this guy? It says it calls a function that takes in a variable R, but boils down to the value of A. If we were writing this in a normal programming language, the value 5 is A, lives and dies with this function. It's only part of the scope for this function here. But inside of this function, when we go and look up the value of A, that environment, that new binding for A still exists in there. So this should boil down to a 5 right here, which is our new binding for A rather than a 7. But if we were writing this in a normal programming language, this should give us a 7, right? If I kind of come down here and I say int A is equal to 7 somewhere up above, then I have my, let's just let me have a main like this. And then we have a function called do something. And do something takes in a variable A. And then I have another variable called do something else that takes in a variable R. And what does do something A do? He calls do something else, passing it whatever we want to pass it. In my case here, I passed it a 22. And then this guy, let's just say, will print out the value of A. Here I would call do something, passing it a 5. So this is, I don't know, C-like pseudocode. So if I have a main, so I've defined A as being 7, so I've added that to my global environment. Okay, I have some other variables in my other global environment, but A is the only one that matters here. So my global environment has a variable named A is equal to 7 in it. Inside main, I call a function named do something, passing it a 5. Do something's taking in a variable called A, which creates a new binding for A is equal to 5. Okay, so now my environment, presuming only these two variables exist in my environment has two bindings. A is equal to 5 and A is equal to 7. I got those two separate bindings in my environment with A is equal to 5 coming earlier. Okay, and because of the way we're resolving, we'll find A is equal to 5 first. Then I'm calling do something else, passing it a 22 in for R, but I'm printing out the value of A. Inside here, inside this function, the value of A should be 7, right? We're looking at this as, Java code or whatever. The value of A inside there should be a 7 because it doesn't know about the temporary environment that was set up right there. Does that make sense? So it should be a 7. And in Java or C or whatever, it would boil down to a 7. But in our language, when we get to this guy, it's going to boil down to a 5 because of the environment in which this guy is extended. We're extending it on the environment because we have an environment passing interpreter. When we go to execute this inner function, when we do this inner call, we're going to be passing our interpreter the environment that already has been extended with A is equal to 5. So as far as this guy's concerned, there is a secondary variable named A, which has a value of 5 that has been bound in the environment, even though it shouldn't be. Does that make some sense? So we call that either a problem or a feature, depending on how we want to represent our language. I would say that it's fair to have the rule that the local environment that is born with a function lives and dies with that function and is not transmitted to other functions that he may call. That makes sense, right? Okay. Which now is showing us potentially a weakness in our environment, our variable environment, just because of the way we're kind of handling it. Really, our issue is this. We don't currently have a convenient way of pulling values back out of our variable environment in preparation to go into the next one, because we're not subdividing things into scopes. We're just throwing every new variable that we might have onto the front of the environment, which up to this point has worked out okay for us. But as soon as, in this particular case, when we go to, well, here we can just look at it in this code. When we call do something else, this guy is getting called within the environment that was not extended as part of this guy. So the environment I need to pass to this dude has to be my original environment. That is the current environment with the most recent scope peeled off, so he can be sent into here. So this guy would then be dealing with that more global A, because he doesn't have access to that local scope that lived and died in here. Now, when we bounce back up here, that scope is back in play, because this guy was already operating off of the environment that had that new scope in it. So he's fine. You know, this is just how recursive calls work. This dude has that scope. When he calls one of his lines of code, this guy right here, he's going to pass with it the environment in which it should be executed. He's just going to deny it the scope that was added for him. So he'll pass the environment to it with that most recent scope peeled off. Does that make sense? So it'll be the cooter of our environment or something like that, presuming that's the way we write it. We write it as a list of scopes, where a scope is a list of two lists. So a scope is like our current variable environment. Okay, so that's kind of a high level thing. So we see the potential for the issue right now. So we will come back and fix that when we talk about, it'll probably be next, actually. We'll have to see. But when we start talking about the idea of an upgraded variable environment that operates on scopes, which feels a lot more like our modern languages do than just a giant collection of name value pairs, because when we start getting variables with the same names, things get a little sketch. Okay, let me get rid of that. So is this properly written no code? Because that guy should boil down to, well, if it was modern language, it should boil down to a 7, but it's going to boil down to a 5. That has to. Oh, because that ends that function, which then gets past this 5 for that call. So now we have an extra one here. And there's our 5, which is the expected answer based on our incorrect implementation, but not the answer that we should get based on how we think a language should work. All right, so we've just, this is the evidence of what we just talked about for the last few minutes. And that's not something we're going to call this good for right now, because that's how we wrote it, right? This isn't a problem right now, other than it's maybe not quite delivering based on our full expectations, but it is accurate based on what we have written. So let's look at our let expressions at this point. What do we want a let to look like? So boring. Is it? Well, yeah, well, because I want you to be creative and come up with interesting stuff and not like let me come up with all the ideas. You got something good? No code let? You were all excited about delivering that as the upgraded answer? What does a let ultimately do? Okay, gives us a local environment, right? Or a temporary environment. You can think about how we want to say, but why don't we call this guy a local environment? That's what it's doing, right? All right, so we fake the code here. So we'll have a local, let's see, for our, I have used the dashes for our syntax up to this point, right? We're going to call this a local environment here. That way, when we parse it, we'll call it a local env, something like that. Just so those two are different, unless we can come up with a better name than local environment. Of course you did. You wrote let and parsed it into let.
No, let expression.
Oh, very creative. It's very Apple of you.
Everything else has been expressed.
It is funny how Apple's like all into design and stuff, but their product naming is like so boring. I do think it's funny, now when people say iPad and things like, we just know exactly, it's become synonymous with like a tablet, right? But when they, how many years has the iPad been out? See, I remember the ramp up time to the iPad. I was, when I was first writing software for iPhone, I was thinking about this iPad thing, and Apple got ripped for that naming for the iPad. They felt that it had other connotations, that they wasn't popular, but it worked out. I mean, like iPhone made sense. So why didn't they call it the iTablet? Or the iPhone ginormous? Or the iPod Touch ginormous? And everybody called the iPod Touch the iTouch, but Apple never called it the iTouch. But they didn't. All they did is kept changing their cable compatibility ports. And Apple sues them. All right, so we're going to call this, let's call this local vars. How about that? Local vars. We're going to create some local variables. So we have local vars, and why don't we create a B7, something like that. And then the body of this guy will be do mathy stuff plus a B. No, well, here, we'll find out. So do mathy stuff plus a B. That's what the body of this guy is going to do. So that ends our local var. So this is the body of our let. That's what that function does. And then we'll go ahead and pass it a 25 for A. So this should give us a 32 as the result of this, right? 25 comes in for the more local A. B is an even more local B, which is 7. So 25 plus 7 should be a 32. Okay, with a slight question of whether our do mathy stuff has parentheses here or not. I think ours does not. So we'll see. We'll see what goes down. So let's add this to our parser first. So I'm going to go ahead and comment out this here just so we can go and we'll test our parser stuff at the beginning. All right, so where's my parser? All right, so this is not a Boolean expression. It's not a function parser. It's a no parser. So what we're going to do is we are looking for the car of our no code. Put it right here. And we're looking for this guy equaling local vars. Okay, so if I'm looking at a local vars, now we need to create our parsed version of this. So we're going to go ahead and we're going to say we're going to create a list. And let's call this guy a let exp. That's ultimately what it's going to be under the hood. All right. Now we need to get the individual pieces of this. So when we look at a local vars, we have our variable environment associated with it. So we can say the car of the coder, that will give us a list of two lists. Oh, that's unfortunate. I thought I kept my cursor up top. The car of the coder of no code. That'll give us our list of two lists. And then the body of this guy will be the car of the coder. Oh yeah, I really botched this pretty bad, didn't I? This is, what did I have in here? B is 7. Yeah. All right. So this is the car of the coder. This is the car of the coder. That's the body of that let. I'm lost. All right. So that's what that guy will produce. Good.
If you want to call, that
Probably. Because that guy is no parse code. The body of it is no parse code. So we actually want to call no parser on that dude. This guy is just a list of two lists, so we don't have to parse that. This guy is just a word, but this guy is more code, more logic, whatever it is. Could be a var expression, could be a lit expression, could be a do mathy expression, whatever. One of those other animals. So we do need to parse it. All right, so that look good for our parser. We should be able to test this now. And oh, I commented out the wrong thing. I just want to see what the parsed version looks like here before we go any further. So here's our code. We should have a call expression that's calling a function. Okay, so we have a call expression. Here's a func expression with a parameter A. We have the body of it, which has a let expression in it, which has a list containing a two list. B is 7, whose body is a math expression plus the var expression A and the var expression B. Those guys should get resolved during runtime. And then let's see, this part looks a little funky. Oh, no, it's fine because we allow for, this is what we added. We allowed for multiple parameters to be passed. It's a list of the inputs. So it's a list containing the parsed version of one of our only input in this case. So this is the parsed version of 25, which is a numlet expression. All right, so parsed code looks reasonable. Okay, and this is the dude that we're adding here, this let expression. I'm gonna steal that here for a second. right. So for our interpreters, we're adding this to a run parsed code. And here we'll put it right before math expression for no good reason. Just we're putting stuff randomly at this point. So car of parsed no code, if that guy is equal to let expression, then we need to go ahead and deal with this. So a let expression at the very least is going to extend our local environment, right? Okay, so we did create a extend DNV where we can produce this and give this guy a list of variables, a list of vars and a list of values and the environment, and he will work with that. I could write another version of extend DNV that, so maybe extend DNV list of pairs, something like that, that does take in a list of name value pairs and produces this. Or we can use map, you're right.
That's not what we're doing.
Oh, go ahead.
Oh,
That's what I heard. I thought it was what I sensed.
let expression always has the list of two lists and then something else.
Correct. Well, the body, yeah, the body of the thing that should happen within that new environment.
So instead of doing that body,
So you want to,
you just call run on.
yes, you could. You want to effectively cons, or you want to append the two list environment onto the list of two lists onto the current environment. In our current case, that will work. But tell me what's wrong with it. Tell me why this is dangerous.
It's not,
It's not dangerous. It's perfect.
it's a feature.
It's our code. We can do what we want.
And you certainly can. And in this case, it would work.
No, it's because it's
That can already-
Yeah, that can already happen. But why is it dangerous to go ahead and this actually has to do with, so I'll give you a hint. This has to do with abstraction. So what is abstraction? Abstraction is separating our knowledge of how something else works with the knowledge that something else does exist. It works the way it works. And we rely on that guy to do the heavy lifting for us. We don't have to know how the ignition in a car works in order to use the ignition. But we also then don't make, unless we're like a, I don't know, like a person who steals cars, we don't have to circumvent that ignition system in order to make it work in a different way. So what you're talking about is fine, but it assumes knowledge of exactly how our variable environments are written. What happens if in the future we change how our variable environments are written? Like here pretty soon, we're going to be working with scopes, and all of a sudden we have code that lives in the trenches of our language somewhere here that is making an assumption that our variable environments work one way. Yet if we change that, now we have code that breaks down here, as opposed to having this code always rely on our do stuff with the variable environment logic. Does that make sense? So in this case, it would work, but it is dangerous this is effectively hard coding a solution based on our current knowledge of something when that something could change. It's probably a safe enough thing to do in a situation where you can sit there and honestly say, would this ever change? And if the answer is probably not, then you can probably just run with it. But in this case, especially since we just talked about it changing very soon, it's probably not necessarily the best idea in the world. But in effect, it is what we're going to end up ultimately accomplishing in our current state. So I like your original idea of using map much better. It's like, are you kidding me? Are you kidding me? So let's look at that first. I'm going to just remove this let expression thing here for a second. Actually, I think I can just, that'll still work, right? Yeah. So what I want to do is we're going to be operating off of I'm going to put a couple other variables in here just for, you know, a bigger example. All right. So ultimately, we want a list of two lists to turn into a list of variable names and a list of values. We want to separate those two things. All right. So at the very least, we need a function that would do that. So we want something that takes in something that looks like this and produces something that looks like ish. Just has those two things separated because those are the parameters we need to pass in to our those are the parameters we need to pass into the extend DNV as it currently exists. All right. So, and forget about map for now. How do I write code that goes through that and ultimately produces something like this? Go ahead. Okay, so part of our issue here is that we want to collect all of the BAs and Zs in our first pass, maybe, and then have a second pass that collects the 7, 5, and 2. So maybe with a couple of helper functions. So we maybe have a one function that produces the BAZ. We have another function that produces the 7, 5, 2. Right? And then we have a function that calls those individual functions on the input. Does that make some sense? So if we wrote that, if we said define, let's call this guy a env let mapper or something like that. And this guy is going to be a lambda that's going to take in a list. So it's going to take in something that looks like this. And we want him to produce something that looks like this. So what we want him to do is we want him to create a list out of maybe our env let get var names function on that list, and our env let get var values on that list. So now we got to write this guy to get var names. This is a lambda that takes in a list. I'm going to write the other one out here too. Get var values. All right, so get var names, his job is to take in something that looks like this and produce this piece. All right. So the way he'll do it is he's going to be walking through that list until it's null, right? So if null LST, we can boil down to the empty list. We're effectively, let's kick this down the line. We're effectively building a list here. Otherwise, what do we want to do? We want to cons the car of the car of our list onto whatever this guy returns on the cooter of our list. Make sense? Now, very similarly, this guy here is going to do almost the same thing, but instead of getting the car of the car, he wants to get the first two lists. He wants to get the cooter of that, and then he wants the car of that. Here's our list. The car of this guy is that dude. The cooter of that dude is the list containing the 7. The car of that is the 7. So it's the CADAR, the CADAR, right? That is the car of the cooter, the car of that, the CADAR. That guy. So he gets the values, he gets the names. Now I will point out, notice that each of these functions do take a single parameter. So you could do this as a scary map and avoid all these extra variable or function names. So you can do it with map. So now this guy will just create a list out of the result of the first guy on the same input as the result of the second guy in that same input. So we should be able to steal this here. And call our env let mapper on that guy. And it should give us our desired output. So there's our list containing BAZ and our, ooh, what hell? I probably didn't deal with the second part of it very well.
Oh, it's still calling, define.
Yeah, it's still calling it the other guy. That's what you get with cut and paste. Now it'll work. So there's our BAZ and our 752. So he is properly separated those two guys now. And now we can use that to extend our environment. Make sense? So I'll go ahead and relocate these dudes up by our environment stuff. Can I put like asterisks and stuff in our other one? Yeah, it looks way better. I have 4 or 5. I have 5. Why should environments play second-class citizens? Almost like they're doing their grocery shopping at a grocery store. All right, so I need to give myself those functions before I forget to paste them. All right, so we want to extend our environment passing it the car of the result of environment let mapper and the catter of the result of environment let mapper to give myself the new environment. All right, so here is this guy. So if we're looking at a let expression, the first thing I need to do is I need to extend my environment to a new environment, right? So I'm going to do this with a let. I'm going to say let new env, and this guy is going to be equal to, actually, let's do it this way. We're going to do a let star, and we're going to call this guy let mapped, wait, I have two parentheses here. Let's call this var two lists, something like that. I want to have this as my intermediate step. And this guy is going to be the env let mapper. It'll be the result of env let mapper, and I need to give it the list of two lists, which is going to come from the car of the cooter if I'm looking at a let expression. As you remember, my let expression here gave me a, let's go back up to this. A let expression, the car of the cooter of that guy is the list of two lists. And that happens to be the kind of animal that I need to send to environment let mapper. To give me that new list of all the variable names and all the variable values. So now I have a variable that's compatible with what my extend env requires. This guy, he requires a list of variables and a list of values and the current environment. So now I can call that guy using those new functions. Okay, that's what I have there. So now I'm going to have the new env. And this guy is going to be the result of calling extend env with the catter of var two lists. Now, why did I use let star here instead of a normal let? What does let star do that a normal let does not? Talked about this last class, I think. Go ahead. I think you're thinking about let rec, but thinking about it incorrectly. Let rec, any of them can store a function. Let recs allow you to have a function that calls itself recursively. That's what a let rec does. But what does a let star do? Nothing. Go ahead. Just something about something. So a let star allows you to define a variable in terms of a previously defined variable in that let environment. A let does not. So a let would not allow you to say A equals 5, B equals A. Wouldn't let you do that. A let star would, but it still operates from left to right. It does require that if you're going to call a variable here, it had to be defined somewhere earlier in that let star. But this is allowed. We're allowed to use a variable that we've previously defined in here that now has a result. Does that make sense? So that's the rationale for using let star. Now, I think I mentioned that you could just say, hey, I'm just going to use a let rec for everything because it works for everything. You know, why have to use our brain to make any sort of decisions? And it's not necessarily a horrible answer, but you know, to get used to the different uses of these things, we'll use a let star and we'll go ahead and give ourselves one variable that's equal to this result, and then call extend E and V on the counter of that guy, the CAA, no, the CADR, the car of the cutter, right? Yep, the second to list, that is this dude. Okay, so this is the car of the cutter. Hold on, I want to make sure I'm extend E and V. This guy looks like this. I'm calling this guy on, it should actually be the car of this guy, right? This is the car, and this is the car of the cutter. Yeah, but that's what extend EMV takes. Extend EMV takes, this is the first parameter, and this is the second parameter. Those whole lists. So I have a list containing those two lists. This gets me the first list in there. This gets me the second list in there. And then extend EMV also takes whatever the current environment is. And that's going to be my new environment in which the body of this let expression should get executed within. So there's my local environment. So now what will I do? I'm going to call run parsed code. Because now I'm executing the body of my let on the car of the cutter. Make sure I got that right. This is the car. This is the car of the cutter. This is the car of the cutter. Will be the body of this. So this is the car of the cutter of our parse no code. But that's being executed inside of our, well, with our new environment that we just created. Thank you. So that's being executed inside of this new environment that we just created. Not the original environment, but our extended environment that we just created inside of this little let here. So that's what we do if we're looking at a let expression. All right, so what should the result of this guy be? $32 is what we decided, okay. So there's our 32. All right, so we've exhaustively tested this. So that should be the homework, right? Now, I probably did this maybe in a little bit less code than you may have done it, unless you made some assumptions about how your environment worked or something, which is fine, as long as we get why that's potentially problematic. And this really is almost the extension of like the early programming lesson of if you're going to use a value in more than one place, put it in a variable and then use that variable in more than one place. That way, in case you change that value, you only have to change it in one place rather than the 40 places you used it. You know, like if you're going to be using pi 3.14 and you hard code that all over the place in your code, but then you decide, you know, I actually need more decimal places. I need more precision to pi 3.14159, yada, 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 whatever. Now you have to go back through and change it. I mean, you could do a search and replace or something, but you get the point. It starts becoming potentially problematic, especially if you've done it through multiple files, right? But if you can give it one global value that's accessible everywhere, and you have had it pi in there is 3.14, you just change it to 3.14159, and now it's everywhere. Go ahead.
So the problem that you have with typing that it was happening inside of code is that
Yes, without using our functions we created specifically for working with environments.
So I just created an invention that just takes in all the fields and the environment. Would that be a
Did you put it up here by the environment stuff? Okay, so as long as it's up here by the environment stuff, so that we're reminded that if we change the nature of our environment, that we can then come in here and when we change it here, we'll change it in one of these other functions down here to make sure it's still compatible. Then it's okay, instead of it being hidden someplace else.
Okay, I thought the issue you had with it was just the fact that it's taking a list of people to put it on instead of like putting it on.
Well, ultimately, this guy does that. Yeah, I mean, this guy does just convert those back to two lists under the front of it. Because notice it keeps calling extend D and B on that guy. So yeah, it doesn't do anything better. It just makes the assumption down in your code that there is a it makes the assumption down in your code that this is how our environment works, rather than rely on one of our environment functions to deal with it. Okay, so let's think. So if we go a step further and go back to our previous example I had in here, where we had a function A which called a function R that boiled down to A. We passed it a 10 there. And we passed it, what's A originally is a 7, now it's a 5. So this guy will give us a value of 5 when it really should give us a value of 7. I gotta have my code written wrong down here. Thank you. I still have it written wrong. Call function A, and the body of that is call function R on the value A that ends that ends that ends that. I have a misplaced parenthesis. So there's our 5 when it really should be a 7, because that A is being resolved in a different function than where A had a new binding. That make sense? So how do we go about fixing that in our current code? If the body, let's go up here. This is our body of our code, right? And you know, actually, if we liked it better, we could have said something like this. Now that looks a little cleaner, right? So we could have actually extracted the body up inside the environment, the let environment, and then call run parse code on whatever the body is and our new environment. That's a little bit cleaner way of labeling it. We literally did the identical thing. I just associated the result of this guy with a variable name and then used the variable name down here. So it's a little bit more descriptive. So it's not like it's any other kind of magic or anything. But if this body, well, I'm just going to ask the question. If I had something like this and I ultimately want the result to be I ultimately want the result to be the correct value, which in this case should be a 7. How do I go about doing that? Okay, so this guy should get called in that in the old environment, right? So if I'm dealing with a call, if that's the kind of animal I'm dealing with, I don't want to run him in the old environment. I'm sorry, in the new environment. I want to run him in the old environment. Does that make sense? All right. So how do I determine if this guy is a call or not? Ask if the, what is it, call expression? In fact, actually, what's the time? Yeah, we'll just do that. So here's the current state of the code. This shouldn't be hard. This should be a comfortable cruise control assignment. Update our interpreter. What's up? No. There we go. Update our interpreter to support functions within functions that should not use the updated environment. An example of one of these is in the current code on Slack. Link to the code and assessment. In this particular example, the result should be 7, not 5. So if you want to, you have your test case there for the assignment. What's up? This is what it does. Every single time you have a function being called inside of another function, the answer is 7. It doesn't matter how yeah, the answer is 7 every time. So working code for let that has a problem with variable scopes. It's too easy. All right. Questions about what I'm asking you to do? What's chapel today? Is it Matins? All right. It's top shelf Matins. It's Butcher Bill Matins. Why? You got to experience it once to just know my pain.
And spelling is that too?
A lot of people actually really like it.
Yeah.
I don't think it'd be for you. All right, I'll see everybody on Thursday.